In this video, we will explore about composition of function. Given two functions f and g, the composite function is denoted by f circle g, or this is read as f composed with g. And this composition can be written in this way. Note that composition of function f of g is not equal to the product of two functions. Let us illustrate function composition using this diagram. We start with input x in the blue circle, then apply the function g and mapping x to g of x in the peach circle. Next, g of x becomes the input for the function f, transforming it into f of g of x in the pink circle. And instead of these two steps, we can combine them into one as f of g of x. The domain of f circle g is a set of all numbers x in the domain of g such that g of x is in the domain of f. Or, in another way, the domain of f circle g is equal to the domain of the result of composition of function intersection with the domain of g. Or, if we will find for the domain of g of f, it is equal to the domain of the result of the composition of function intersection with the domain of f. For example 1, given function machines f, k, g, and h defined as follows. For the function machine f, it is given as an equation x squared minus 1. So let us try to evaluate at some values of x, like f of 0, by putting 0 in every x in the given function. So f of 0 is 0 squared minus 1, which is negative 1. Another is f of 3 by putting 3 for every x. So 3 squared minus 1, which is equal to 8. Another function is k of x, which is equal to 3, and this is a constant function, meaning for every input x, there's only one output, which is equal to 3. So if you will evaluate k of 0, it's equal to 3. K of 2, it's also equal to 3. Another function is the function machine g, which is given as a table of values. So if we will evaluate g of 1, the answer is 3. And g of 2, the output is a minus 3. The last function is the function machine h. If we will evaluate h of negative 4, when x is equal to negative 4, the y value is equal to 2. And h of 2, when x is equal to 2, the y value is 0. So let us find this composition of functions. First is f of g of 1. So to find f of g of 1, let us start by the innermost function, which is g of 1. In finding for g of 1, we will base on the table of values in the function machine g. So g of 1 is equal to 3. Then, finding f of 3, we will evaluate from this equation x squared minus 1, so 3 squared minus 1, which is equal to 8. So f of g of 1 is 8. Next is g of f of 2. The innermost function is f of 2. So in the function machine f again, place 2 in x. 2 squared minus 1 is equal to 3. So f of 2 is 3. And then evaluate g of 3 using this table of values in the function machine g. G of 3 is equal to 4. So g of f of 2 is 4. Next is k of h of negative 4. the innermost function is h of negative 4. So we will base on the graph of h. When x is negative 4, the y value is equal to 2. So h of negative 4 is 2. Then let us evaluate k of 2. K of 2 is this constant function. For every x, the output is always 3. So k of 2 is equal to 3. So the composition of function k of h of negative 4 is equal to 3. Next composition is h of minus 1. So the innermost function is h of minus 1. So based on the graph, when x is minus 1, the y value is equal to minus 3. So h of minus 1 is 3. Then next, h of minus 3 is equal to, you will base again in the same graph. When x is minus 3, the y value is 0. So h of minus 3 is equal to 0. Next is h of g of 5. So let's find first the innermost function g of 5. So based on the table of values, g of 5 is equal to 5. So we will now evaluate h of 5. And when we find h of 5 based on the given graph, h of 5 is undefined because when x is equal to 5, it is not included in the domain since it's an open point in the graph. So it is undefined. So h of g of 5 is undefined. In the next example, given the two rational functions f and g, then we will find f of g of x and then simplify the answer. So we will show this in two ways. So in finding for f of g, we will put the function g inside the function f. So it means we will place this x over x plus 3 for every x in the given function f. So it will be equal to this. Then simplifying this, we can see a fraction divided by a fraction. And to divide two fractions, we have to make sure that the numerator is one fraction and denominator is also one fraction. Since denominator is not a one fraction, we have to subtract 4 in this x over x plus 3. And we cannot subtract this whole number to a fraction if they don't have the same denominator. Since we know the denominator of 4 is 1, so we have to make sure that they have the same denominator to be able to subtract. So the next method here is, we will multiply this 4 by x plus 3 over x plus 3 so they can have the same denominator. So the numerator we will just copy, and then for the denominator, since they now have the same denominator, so we can write the denominator, which is x plus 3, and then we can now combine the numerators, which is x minus 4 times x plus 3. And then, since we can see now one fraction in denominator and one fraction in numerator, so we can change this division to multiplication. So copying the numerator, which is x over x plus 3, then change the division to multiplication, and then we can get the reciprocal of this denominator. So multiply by x plus 3, and this numerator will be written in the denominator. And at the same time, we distributed negative 4 in x plus 3 to have negative 4x minus 12. Then after that, we can now simplify by canceling out the common factor appeared in numerator and denominator, which is x plus 3. And then we can finally write the results as x divided by negative 3x minus 12, because x minus 4x is negative 3x, and then copying negative 12. So this is f of g. For another way, so let's start again with f of g. And we know that when we put g inside the f, so we have this given complex fraction. And initially, what our aim is to get rid of this x plus 3, which is the denominator. So what we're going to do, we will multiply this with x plus 3 over x plus 3. We are multiplying, in this second method, we are multiplying this x plus 3 over x plus 3 in the whole fraction. But in the first method, we just multiply this x plus 3 over x plus 3 in the denominator. So let us see the difference between them. So if I will multiply this x plus 3 in this numerator, this x plus 3 will cancel out, and the answer in the numerator is only x. And then if I will multiply this x plus 3 in both of this, so let us start first multiplying x plus 3 in the first fraction. So it will give us x, because this will cancel out this x plus 3 and x plus 3 here. So it's x. And then another is, to continue, we will multiply x plus 3 in this negative 4. So the product will give us minus 4 times x plus 3. And then simplifying the denominator, we will get x divided by negative 3x minus 12. So it is the same in the method 1. Now, since we solve f of g of x in part A, which is equal to negative x over negative 3x minus 12, then for the part B, we will find the domain of f of g in interval notation. So let us recall the formula for finding the domain of f circle g. It is equal to the domain of the result of f circle g intersection with the domain of the innermost function, which is g. So first, let us find the domain of the results, or f of g. So f of g is equal to this fraction, and as we know, in finding the domain of a fraction, denominator cannot be 0. So it means we will start putting negative 3x minus 12 not equal to 0, or negative 3x is not equal to 12, or x is not equal to negative 4. So it means to say the domain of the result is all real numbers except negative 4. And then after that, let's find for the domain of g. So our g is a fraction again, and as we know, in this fraction, denominator cannot be 0. So we will start by putting x plus 3 not equal to 0. So x is not equal to minus 3. So the domain of g is all real numbers except minus 3. If we will get intersection of these two, so we can say that the domain of f circle g is all real numbers except negative 4 and negative 3. And if we will write that in interval notation, it's negative infinity to negative 4, union negative 4 to negative 3, union 3 to infinity. For example 3, given functions f, which is a linear function, and g of x, which is a radical function, find g of f of x and simplify the answer. So in finding for g of f, so this time the innermost function is f of x. So we will put the function f inside the g. So we can come up with square root of the square root of x plus 2, because we place x plus 2 in x, then minus 4. Then simplifying or expanding this square root of x plus 2, it will give us x squared plus 4x plus 4, and then minus 4. And then subtracting this 4 minus 4, it will give us 0. So we will have x squared plus 4x under the root. So that is the value, or the value of g of f of x. Then for the part B, we will find the domain of g of f of x in interval notation. So let us write the formula for the domain of g circle f, which is equal to the domain of the result of g circle f intersection with the domain of the innermost function, which is f this time. So let us find first the domain of the result. The result of the composition is square root of x squared plus 4x. And as we know, in this square root, the radicand, which is x squared plus 4x, should be always greater than or equal to 0. So we can start from there. X squared plus 4x is greater than or equal to 0, or factoring this, it will give us x times x plus 4 greater than or equal to 0. As we can see here, these two expressions, the product of these two, is positive in two cases. If both of them positive and both of them negative. Since there are two cases, so we are using sign analysis. And as we know, this is a quadratic inequality. So in using sign analysis, we will identify the values or the zeros here, which are 0 and negative 4. So writing negative 4 on the left and 0 on the right. And then after that, let us test the sign on the right side by choosing a number on the right of 0, which is 1. and then put 1 in the given function. 1 times 1 plus 4, it will give us a positive value. So this side, the product of these two expressions is positive. Then after that, we can get the sign of the remaining by checking on the powers of this x and x plus 4. The power of x is an odd, which is 1, and x plus 4, the power is also an odd. If the multiplicity or powers are odd, it means the signs are changing. So positive on this right side, so on the left side is minus, and on the left side of this is a positive. So now, since what we want here is a positive, so the solution for this domain of the results is on these two parts. So we can write that in interval notation from minus infinity to negative 4 included, then union from 0 to infinity, 0 included. Then after that, we can now find the domain of f. And since the f is a linear function, we know that the domain of a linear function is always all real numbers. Then getting intersection of these two intervals, intersection with the real number, the answer is this, because this is a smaller set than set of real numbers. So the answer is this.